Suppose the ceiling in the previous problem is that of an elevator. Ceiling is ceiling of an elevator. You know, elevator, lift like structure, which is going up with an acceleration of 2 meters per second square. Find the elongations. Okay, so first of all, let us try to picturize this. The same picture what we have discussed in the previous problem. So what was the picture, children? A ceiling was given through which a spring was being suspended, and to this 2 kg mass was given. The same thing, and the whole apparate thing was kept inside an elevator. This is an elevator, lift-like structure, and also given that the lift or the elevator is moving upwards with an acceleration of 2 meters per second square. And already we know that in the previous problem it was given that value of k is equals to 100 Newton per meter. So clearly, as the elevator is moving upwards, we have upward force is greater than that of the downward forces, and let us try to identify the two forces acting on them. So what is the upward force, children? Upward force is nothing but spring force, taken as Fs or simply F. Spring force, Fs or F, and the downward force is the weight of the body, mg. Upward force is spring force and the downward force is mg. So as the elevator is moving upwards, so what is the resultant equation, children? Upward force minus downward force is the net force. Net force means F net we can replace with. Or Fs. What is the formula for Fs? F is equals to, inside the spring, we know that the value of F is given as Kx. Magnitude of F is given as Kx. Spring force, or Fs can be written as Kx minus mg is equals to ma. Clear? So based on that, let us try to solve the equation. So bringing this minus mg the other side, we have Kx is equals to mg plus ma. What is that, children? mg plus ma, but what is common in both? Ma is common, so let us take out m as common. Then you are left with kx is equals to m into g plus a, or x is equals to m into g plus a upon k. Substituting the values, you can find the elongation in the spring. X indicates because of the suspended mass, the spring will be elongated a little, and that elongation is given by x. So the value of x is equals to mass is 2, gravity, acceleration due to gravity is 10, acceleration is given as 2 upon the value of k is 100. So solving this, we have 2 into 12 upon 100 or 0.24 meters. What is the value? The extension in the spring was found to be 0.24 meters only when 2 kg mass is being suspended. So this is your case 1, first case. Only when one particular mass is suspended. But in the previous problem, what was given? After 2 kg mass, one more mass was also suspended, and that mass. So let us picturize the second case, children. In the second case, if you observe that, let us picturize this once again now. So along with the 2 kg, one more mass was also being suspended. What was the other mass? The same suspension, the same spring. So along with the 2 kg mass, we have also suspended one more mass, that is 1 kg mass, and again the whole apparatus was kept inside an elevator, and this elevator was going up with an acceleration of 2 meters per second square, and the value of k is, as usual, we have 100 Newton per meter. So again, in the spring, some spring force must be acting, and that is given as Fs. Spring force is given as Fs. But are these two spring forces same? Not at all, because of the 2 kg suspension, some force was acting, that Fs I have considered. And in the second case, along with 2 kg, one more mass is also suspended, that is 1 kg. Hence, the force will be something new. So let me name it as, instead of Fs, that new spring force, let me name it as Fs dash. Okay, very clear. As it was given that the elevator is accelerating upwards Okay, so the net force can be given as the upward force minus downward force is equals to MA. So what is the upward force, children? We have the upward force as Fs dash minus downward force is new mass. Earlier only 2 kg was suspended, so mg. Here 2 plus 1, 3 kg mass is suspended, so new mass is suspended. Okay, the value of mass changes, so m dash g. Okay, upward force minus downward force is equals to net force. So net force is F net. What is Fs dash, children? Fs dash is equals to, formula for Fs is F equals to Kx. Fs dash means new extension Kx dash. So I replace this with K because K will never change. It's the same old spring. So K is same, Kx dash minus m dash G must be equals to m dash A. I hope the concept is clear. So now Kx dash or Kx dash can be written as minus mg dash. Taking the other side, we have m dash into g plus a. Same like this, minus will become plus upon k also. If I brought it downwards, m dash into g plus a upon k. Substituting all the values, we get x dash as, what is the new mass, children? Along with the 2 kg, 1 more kg is there totally. That is, you have 3 kg mass into g. The value of g is how much? 10. Acceleration is 2 upon the value of k is now 100, or x dash is found to be 3 into 12 upon 100. That is 24 upon 100, or x dash is equals to 36 upon 100, or x dash is equals to 0.36 meters. Clear? Because of the extended mass. So what is the elongation that was found when additionally 1 kg mass is suspended was 0.36 meters. Only when 2 kg mass is suspended, the elongation was found as 0.24 meters. So what is the difference in these elongations? Let us also calculate the same. So in order to find out the difference in the 2 elongations, that is delta x is equals to higher mass suspension, total mass suspension subtracted by the single mass suspension. So delta x is found to be, x dash is 0.36 upon subtracted by 0.24. Hence, okay, difference in the elongation. They are only asking us to find the elongations individual, this elongation and this elongation. I am also trying to find out the difference in the elongations. What is the difference in the elongations? It was found as 0.12 meter. This is an additional part which we have calculated. Okay, so now moving to the next question, that is question number 10. So look at this, children. A block of mass 0.2 kg is suspended from the ceiling by a light string. So a light string is there at to which 0.2 kg mass is suspended. A second block of mass 0.3 kg is suspended from the first block. So let us picturize the same. So what is this, children? To the suspension, a string is there, light string. Only a string was given, not spring. A light string was given. This is better. To which a block of mass 0.2 kg is being suspended. So this is a block whose mass was given as 0.2 kg. And what else was given? A block of mass 0.2 kg suspended from the ceiling by the help of a light string. A second block of mass 0.3 kg suspended from the first block. Again, to this first block, one more block was also being suspended. Let us take it as. So this was the second block given as 0.3 kg suspended to that block with the help of another string. With the help of another string. You are asked to find the tensions in the two strings. So children, let us suppose that the tension in the first, here the down string is T1, tension in the up string be some T2. Let us suppose that. Okay. So you need to just find out the values of the tensions. So you are already familiar with the free body diagram. So let us first of all write the free body diagram of the first body. So if you take the first body means this mass is M, I'll take, downward is G, upward is T1. So this pink color, I just replaced it here. So we know that value of mass is 0.3 kg. Is it accelerating? No, it's simply, it is suspended. Okay, so now upward force must be equals to downward force. What is upward force? T1 must be equals to downward force is mg. T1 must be equals to mg, or T1 must be equals to, what was the mass given, children? 0.3, and g value are asked to take it as 10 meter per second square. So into 10, or T1 is found to be 3 Newton. The value of the tension is found to be 3 Newton. Is clear? But you are asked to find out the tensions in the two strings. So first string, we found it as 3 Newtons. Let us also try to find out the tension in the second string. In order to find out the tension in the second string, let us again suppose the free body diagram for the second string. So here the mass is there m, upward force we named it as T2, and the downward force we named it as T1. Clear? So, but what is the mass, children? If m mass is there, later on I'll consider it. If m mass is there, here mass, let me name it as some m1 to make you clearly understand. This is m1. m1 indicates your 0.3 kgs. But here you have another mass that is 0.2 kg. So I'll name it as m2. So no doubt its weight is acting downwards, m2g. So to this block, tension T2 is acting upwards, and the weight of the block mg is acting downwards. But if you observe it carefully, along with mg, one more force is also acting downwards, that is tension. Tension T1 is acting along the string downwards. So along with m2g, you have one more force, that is T1 is acting downwards. This should be clear, children. So how many forces are acting upwards? Only one force, that is tension T2. How many forces are acting downwards? Two forces, that is one is weight of the body, the other is tension due to the first body. So T1 in downwards. So now we have, as the string is simply suspended, not accelerating up or down. So upward force must be balanced by the downward force. So what is the upward force, children? T2 must be equals to, what are the two downward forces? One is T1, the other is m2g. So what are the two conditions? T1 plus m2g. Is that clear? Upward force must be equals to downward force. T2 must be equals to T1 plus m2g. Now you are asked to find out the value of T2. So T2 must be equals to, what was T1? We already found it as 3 plus mass. M2 mass is how much? 0.2 kg into the value of g is 10, or T2 is equals to 3 plus 0.2 into 10 is found to be 2, or T2 is equals to 5 Newton. Hence, the two tensions are 3 Newton and 5 Newton respectively. So all clear? Well, so let us move to the next question, that is 11th one. Two blocks of equal mass. How are they? Equal mass M are tied to each other through a light string. Let us picturize the same. So two blocks are given, block 1 and another block. Two blocks. So two blocks of masses, same mass. What is if this is M, here also it was given as M. Two blocks of equal masses M are tied to each other. So it was tied to each other, something like this, with the help of a light string. Is all okay? One of the block is pulled along the line joining them with a constant force. Either of that you can imagine. So what else was given? One of the block was pulled along the line. This is the line joining, and with a constant force. How much force it is pulled with? It is pulled with some constant force F. Find the tensions in the string joining the block. So in this string, some tension must be acting in the string. You are asked to find the tension in the string. First of all, instead of before trying to solve tension T, let us first of all try to solve the acceleration. So children, whenever a force F is applied, two blocks will be accelerated, same acceleration. So clearly we have acceleration of the two blocks will be equals to net force upon the total mass. Okay, or acceleration of the two bodies is found to be, what is the net force acting? F upon, what is the total mass? M plus M, that is 2m. Hence, acceleration, both bodies will be moving with same acceleration, and that acceleration was found to be how much, children? F upon 2m. Okay, up to this it is clear, I think. So now let us try to find out the tension in the string. So clearly we know that this tension T is only pulling this mass M. So we have this value of tension T came as T must be equals to, observe this, T is pulling this mass M, so T must be equals to MA, or T must be equals to M times of F upon 2M. So simplifying this, children, this M and M gets cancelled, and hence the value of T is F upon 2. So how much is the tension acting in the string, children? The tension in the string is found to be half of the total force. Because of two equal masses, so force is also distributed equally. Half force is applied for this mass and half force is applied for the other body. Clear? So answer is tension in the string was F by 2. So now moving to the 12th question, children. Two blocks A and B of masses MA and MB. First block mass is MA and the second block mass is MB. Respectively are kept in contact on a frictionless table. So first of all, let us try to understand this. So what is given? There was a table was given. So it was given that on a frictionless, smooth table or a frictionless table, two blocks of masses, different masses are kept. So what are the two different masses? One, they named it as MA, and other, they named it as MB. Yes. So one mass was MA, another was MB. So two blocks A and B of masses MA and MB respectively are kept in contact on a frictionless table. The experimenter, where is the experimenter? So here, so what happens means there is an experimenter. Okay, so there is an experimenter. What is he doing? Experimenter pushes the block A from behind so that both blocks accelerate. So this person, he is trying to push this block. The experimenter pushes the block A from behind so that both blocks accelerate. If the block A exerts a force F on the block B, this is the block A which exerts a force F on block B, what is the force exerted by the experimenter on A? So let us suppose that the experimenter exerts a force of F down, because MA is exerting F, it was given in the question itself. So we can't use F here. So some new force is exerted by the experimenter on the block here. That force you are asked to find out. What is the force exerted by experimenter on MA? So you are asked to find that new force F dash. But before finding out F dash, let us try to get some relation for F. So clearly there is some contact force between MA and MB. Okay, and that contact force pushes the MB towards the other side. It's very clear. But as the experimenter is pushing, holding the block MA and pushing together, both the blocks will be accelerated with the same acceleration. Both the blocks will be accelerated with the same acceleration, and that acceleration is given by the net force upon the total mass. So what is that value, children? The net force is, how much force is he applying? F dash upon the total mass is found to be MA upon MB. This part is clear. So the net acceleration produced in both the blocks is F dash upon MA plus MB. Keep it aside. So now coming to this condition, that is F dash. This F dash, what is this F dash making? First of all, observe this F. What is the value of F, children? Clearly we know that the value of F equals to mass of the second body. This F only pushes the second body. So mass of the second body into acceleration of the second body. And the value of F equals to MB times of A. Let me replace it with F dash upon MA plus MB. So I can rewrite the value of F as MB into F dash upon MA by plus MB. Clear? But what you're asked to find out? You're asked to find the value of F dash. Clear? You're asked to find the value of F dash. So let me write this down to make you more clear. So what is the value of F equals to, children? MB times of A is F dash upon MA plus MB. I would like to find the value of f dash. In order to find the value of f dash, I need to bring the all other leftover terms to the left side. So whenever I bring these factors to the left side, the denominator will come to numerator and the numerator will come to denominator. Hence, keeping this f dash here, we have the total term to the other side. What is the total term, children? MA plus MB. Okay, this will come reciprocal by MB into F is the value of f dash into F is the value of f dash. So that's it, children. Or simplifying this further, we have f dash is equals to, let us separate the variables. The denominator is common to two terms, so I can write it as MA upon MB plus MB, separating the variables, upon MB into F. So f dash is equals to separating the variables. Or finally we have f dash is equals to MA upon MB plus, they both will get cancelled and you are left with 1 time of F. So how much force is exerted by the experimenter, children? He was exerting 1 plus MA upon MB times of the force exerted by the block A on block B. Got it? So now let us move to the next question, that is question number 13. So two blocks, they have given the picture, so no need to imagine the picture and all. So two blocks of masses 4 kg and 2 kg are placed side by side on a smooth horizontal surface as shown in the figure. So given a horizontal force 20 Newton is applied on 4 kg block. Find the acceleration of each block. So what is the acceleration of each block? We have the one and only one formula. So what was that, children? Acceleration of each block is found to be net force upon the total mass. Or acceleration is found to be, what is the net force they are acting? 20 Newton upon total mass is how much? 4 plus 2. Okay, 4 plus 2 is total mass 1 and mass 2. 4 plus 2 is 6. Hence, after solving this, we get it as 10 by 3 meter per second square. No need to solve it further. So simply, what is the value of the net acceleration? The value of acceleration of each block is found to be 10 upon 3 meter per second square. Okay, so this is the first part they are asking us to find out. A. And what else was given? The normal reaction between the two blocks. So between the two blocks, somewhere here, that because of the contacting surfaces, this contacting surface exerts some perpendicular force here. Okay, what is that perpendicular force is given by surface on the block is nothing but your normal reaction, and the direction of normal reaction will be something like this. So this 4 kg mass is exerting some normal reaction on this. As a result, this will equal and opposite force will be acting in the opposite direction. That normal reaction you are asked to find out. It's nothing but a contact force. We generally name it as F. Previous example we named it as F here. And here the same contact force you're asked to find out, whether you name it as N and as a normal reaction, F as contact force, whatever it is. Because they asked as a normal reaction, I named it as N. Suppose if they ask it as some contact force, I may name it as F. If they ask it as reaction force, I may name it as R. So the names can be anything, but the concept is same. Okay, so I'll ask you to find that contact force or the normal reaction force acting between the two bodies. So very clearly, because of this normal reaction force, the 2 kg block is pushed aside. So both are accelerating with same value, A and A. So this normal reaction force pushes this mass the other side. So if you go with concept number B, the normal reaction force must be equals to mass of the second body into acceleration of the second body, or N can be written as mass of the second body is 2 and acceleration is 10 upon 3. Hence N is found to be 20 upon 3. So N is nothing but normal reaction force, and units for this is Newton. Units for this is Newton, indicated with letter capital N. So you may get confused between N and N. So the reason why I wrote in a complete words as Newton. So what was the value found here? 20/3 Newton. So acceleration was 10/3 meter per second square, whereas the normal reaction force is 20/3 Newton. Okay, got it? So well, that's all. Moving to the next question, that is 14th question. 3 blocks of masses 3 kg, 2 kg and 1 kg are placed side by side on a smooth surface as shown in the figure. So how many cases? 1, 2 and 3. Totally how many cases were kept? Total mass is 3 plus 2 plus 1, that is 7 kg mass. A horizontal force of 12 Newton is applied on 3 kg block. Find the net force on 2 kg block. Again the same contact force or the normal reaction force you are asked to find out on this 2 kg force. So before that, let us try to find out the acceleration. The net acceleration is given by the net force upon the total mass. So very clearly the value of A is found to be, the net force acting was 12 Newton and the total mass is 3 plus 2 plus 1, that is 6 kg. 3 plus 2 plus 1, how much is that? 6 kg. Or acceleration is found to be 2 meter per second square. But you're not asked to find out the value of acceleration. What you're asked to find out? The horizontal force acting on the 3 kg block. So moving to the next step, we have case 2. So let this be case 1 and case 2. If you find out acceleration of net force, F is equals to mass into acceleration. So what is the mass? Not only 2 kg. Here because of this contact force, 2 kg as well as 1 kg both are moving up. So the net force that is acting here is F is equals to mass into acceleration. But what mass is moving? Not only 2 kg. Maybe the force is in contact with 2 kg, but because of this force both the bodies are moving together to the other side. So the total mass on which the total force is acting is 3 kg into acceleration was all the blocks were accelerating with same acceleration A, and that A value is found to be 2 meter per second square, or F is equals to 6 Newton. Hence, the contact force that is acting on 2 kg block is found to be 6 Newton, children. All okay? So, well, now moving to the last question. Here we go. In the arrangement shown in figure, the strings are light and inextensible. The surface over which blocks are placed is smooth. Well, as if A is equals to F net upon total mass. So A is equals to, what is the net force? All blocks are pulled with some force. What is the total force with which the all blocks are moved, children? That is 14 Newton upon total mass is 4 plus 2 plus 1. Here it is 7 kg. Our acceleration is again 2 meter per second square. So what was the acceleration of each block, children? So it was found to be 2 meter per second square. What else was given? The tension in each string. You're asked to find out the tension in each string. Let us name the tension in this string as T1. Tension in this string as T1. It sounds bad. Okay, T1. And here the tension in the second string be something like T2. So you're asked to find out the values of T1 as well as T2. So first of all, let us try to find out the value of T1. Let me change the color. So first of all, to find out the value of T1, very clearly this tension force T1 is pulling only one block, that is 4 kg mass. Hence, let this be first part. In the second part, we will be finding the value of tension. This T1 is pulling only one block having mass 4 kg. Formula was MA, or T1 is equals to mass is 4 kg, and acceleration we have just found out. What are the acceleration, children? All the blocks are moving with same acceleration, and that value was 2. Hence, the value of T1 is 8 Newton. So, tension in this particular string is found to be 8 Newton. Similarly, let us also find out the tension in the second string. So it's very clear that because of this tension force, both the blocks are pulled together with same acceleration. So T2 is pulling 2 kg mass as well as 4 kg mass. Hence T2 is equals to again MA, some new mass into A, or what is the new mass here? 2 plus 1, that is 6, and acceleration is 2. Hence the value of T2 is 12 Newton. So what are the tensions in each string, children? The tensions in each string are 8 Newton and 12 Newton respective. So with this, let us conclude this worksheet and let us meet in the next concept. Okay, until then, take care. Bye-bye.